Hello everyone. Today we talk about solutions that work and not like those vending machines who say that light within me is off, but I still work, right? So that's not about us. I have nearly 20 years of my career, and throughout this career I met a lot of different people. Now, as an engineering manager, I can tell you that there are only two types of people that you will observe. You either admire people or you eventually fire them. So I hope that this talk today will help you to be in the first category. All right. And thankfully, I only had to fire only a handful of people during those years. But there were many people that I were admiring. And one of those people was Nikolai Ashanin. We went through together a lot. So during our years in EPAM, we were going through Solution Architect School together. We were struggling with architecture challenges. And then later, we made the biggest mobile conference in Moscow, like 8 years ago. So that was an awesome experience. But why I'm talking about Nikolai in particular is that he actually fulfilled my old idea. I will tell you about it right now. So how many of you have little kids at home? Okay, quite a lot. That's why you came here today, right? Hope not. I have a kid at home as well. And I remember that many years ago, I was struggling with kids' cry, right? So you don't know what's wrong with him or her. Like the diaper is dirty, they're hungry, they're bored, they just, I don't know, decided to cry. So I was thinking that time that would be nice to have a mobile application to actually know what's this cry about. Yeah, debug, exactly, like an engineer, you know, measure the frequency or something. So, but I never had the time to actually put an effort into building such an application, and I didn't have any idea where to even start. But Nikolai actually fulfilled this. Like, this is not a promotion. I won't even give you the name of the app, but he built an app, and they reached 1 million users. So they found some data sets in the internet, trained the model, built the mobile application. I haven't tried it yet, but like 1 million people tried it out, and like looks good. So why I'm telling you about this is that probably everybody wants to build an application that has 1 million users. Who wants to do that? Raise your hands, don't be shy. Okay, so almost half of them. That's great aspiration. So everybody thinks about that. I'm not sure I'm gonna give you a list of ideas or the exact blueprint how to build such an application, but I hope that by the end of this talk, you will get some ideas of like what is the guidance, right? So where to start, what are the common pitfalls to avoid, what to do in general, all right? And why we need to talk about this is because unfortunately we are engineers and we want to solve every problem as an engineer. And what I see in the internet, in my real life, in the cases with a lot of my colleagues, is that people will jump into engineering work right away. Multiple stories that I saw was that, hey, I'm a new CTO, I'm building a product, and I'm starting with Kubernetes right now, right? And then half a year later, the startups go bankrupt because they didn't build anything that could bring revenue, but they have a huge pile of shiny technical products that nobody is using. So we need to avoid this, right? So the complexity actually kills. So if you overdo the product, you will spend the time not in building something useful, but rather something to enjoy yourself while you're building it, right? So this is a big problem, and we need to avoid this. Actually, no one cares about the tech, right? So when you download an app, be it a Bolt app or Deliveroo or a banking app, do you really ask yourself, hey, is it built with React Native? And if it does, do you uninstall it? No, you don't. Because you as a customer don't care, and customers overall don't care unless they have real difficult problems, unless the application crashes, or it's sluggish, or any other problem, but that's a product problem, okay? That's not technology problem. So next time you're building a new app, a new solution, think about customers first. Don't think that I'm gonna use TypeScript, or I'm gonna use Go, I'm gonna build it in Kubernetes. No, ask yourself what my customer wants. And I will give you some ideas of how to think about it in the first place. So again, hello everyone, my name is Vladimir Ivanov. I'm a CTO and co-founder of the company that is called Supply.EE. We have a website, GetSupply.EE. What we do, we build infrastructure for digital marketplaces to help them with compliance. If you're interested in what it is, I will talk about it later. Why I'm talking about this is like some kind of credentials, right? So we reached product market fit. We actually proved that what we're building is required for the companies out there. We secured 1.6 million euro in a pre-seed round, and we have like a couple of years of run rate to extend our solution and to go to the new markets. And like in my previous work, I managed the departments with roughly $5 million of annual budgets. So looks like I may know what I'm talking about, but apparently I can be wrong. So how do we make the solutions which actually work? Well, actually, we need just 4 steps. So every business on this planet actually does this. So first of all, it solves some kind of a pain. Okay, so if you imagine a bank, what do they do? What do they think bank is doing? Banking app. Money what? Stealing money. Okay. Well, I'm not sure they would live long enough if they would just start stealing money. Well, they provide you with a convenient service, right? So they safeguard your money, and they provide you a convenient way how to exchange it, how to pay for goods, how to transfer it to your relatives, and so on and so on. What does Bolt app do for you?
Food.
Food, okay. So they actually feed you in exchange for your money. What else?
That's it, right? Connecting people.
Connecting people, I thought that was vodka, that's okay. Well, yeah, so Bolt app, what is doing for you as a customer, they would get you from point A to point B. For the driver, they would provide them with the mean to survive, right? So they earn money through this application. Okay, and there are tons of other examples. So every application, every software, every product, they actually solve some kind of a pain or a problem, right? But before building something, it is worth knowing that the problem worth solving, okay? Both inside businesses and in customers' life, right? So if you think about some kind of a problem, and then you will think, okay, I will build an app for that. For example, I don't know, some kind of a book of recipes, right? So you will probably figure out that that's not a problem at all, right? So people do not struggle to find the recipes on the application because they can just call a friend or find something in a book or just experiment themselves. So not every problem that you would come up with actually worth solving. Same happens in the businesses, right? So when we look at the business processes, for example, customer support or reporting or something else, we will say, okay, but we actually can write a program. But it doesn't mean you should just because you can, okay? So sometimes automating something costs much more than the problem itself. For example, like a famous joke was about when a developer wants to make a wedding, and they need to send the invitations to their wedding. What the developer would do, instead of handwriting the invitations, that would write a program, deploy it to Kubernetes, and start sending it, right? For one-time job. So not every problem requires automation. So we need to know about it and validate the problem worth solving. Next thing, if you somehow validate it, we'll talk about that in a minute. The next thing what you do is you build a first version, right? So you try to come up with some kind of a solution and then see if it sticks. This is exactly what we do, what we did in Supplied. So what we do, briefly, one of the things that we do is preparing the tax reports for digital marketplaces. So imagine your Bolts, or your Etsy, or your OnlyFans, or some other marketplace, and you just connect different users between each other. Actually, there's a European regulation that demands those marketplaces so that they report on the earnings of their suppliers. So actually, this is a tedious operation because you need to prepare data, come up with some format, then convert it to XML, and send it to the tax authority. So what we did as a first version, we built a mere converter from a certain CSV file into the XML. So it wasn't great, it wasn't very convenient, but it solved a very particular pain of preparing the report and sending to the tax authority. Right now we're extending on this vision, we're preparing a data orchestration engine and so on and so on, but we first built a very ugly but working solution which actually helped us to reach the PMF and eventually secure around. So first version is a must. And then what you do? You just iterate, right? So you go to the customers, you get the feedback, you improve the product, and through this way you grow. Let's try to dig deeper into each of those pains. So every time you start with finding a pain to solve. However, the important caveat here is that the pain that you somehow understand, okay, at least somehow. Because if you try to solve, for example, a huge medical problem, when you haven't even heard about any of the medical approaches, well, you're likely to fail. That's why when investors search for the companies to invest, first thing that they look at is not even the product itself, but rather the team and how the team knows about the product itself. So in our case, why investors believed in us was because we have the relevant experience during this DEC7 regulation during our time at Bolt. So we had the hand-first experience about the problem that we're solving. So they believed us. So first, you need to find the pain to solve, and you need to have at least some understanding about this pain. Otherwise, like the chances that you will be lucky will be low. How to find such kind of idea? Well, actually, every one of you can start right now. So if you go to Google Trends and you just check out what is trending request in Estonia in Google, so you will find Tulu declaration, mai idea, mis on Tulu declaration. But I know what is Palga calculator, right? So this is a salary calculator, and this looks promising. And actually, by the end of today's presentation, we will have a functional salary calculator. So bear with me. Okay, so basically, you need to understand what is used by or demanded by big enough amount of people, and build some kind of a solution to ease this pain. Okay, that's very good. Then, once you figure out that there's a problem, then you need to understand it better. And the typical approach would be to come up with some kind of idea or a solution and then start pitching it to end customers, okay? So you will go to some company that you have a fancy solution and will start asking, will you buy it? What do you think such people hear as a response to the question like, will you buy this?
Like no, because like each client would like to be the second one.
Okay, that's a good idea. Any other ideas?
I would expect.
They just say yes.
No answer? Okay, yes?
Yeah, they just say yes, but no.
Exactly, exactly. This is what happens in the majority of the cases. So people don't want to disappoint you, okay? They don't want to hurt you. They want to be nice. So they would say, yes, but give me this feature. Or yes, but next year. Or yes, but we're waiting for the funding, and so on. And they will disappear. So they will stop replying to your questions because actually your solution doesn't fit. Who knows what to do? What is the right question?
Ask how they solve problems at the moment.
Exactly. So what I recommend is to read or listen, in my case, to the book that calls Mom's Test. So you can treat your customer as your mom, right? So if you go to your mom and ask, hey, I built this solution, what do you think about it? Will you buy it? She will tell you, of course I will, right? But that's the wrong question. The appropriate question is, what do you do right now? How big of a problem it is right now, right? So you need to gather information about the current problem rather than pitching your solution. And this is the whole book about. I'm not going to citate it for you. I want you to have this pleasure of reading or listening to this book. But the idea is that gather information instead of pitching. This is how you get the insights. So recently we were talking with Bolts, by the way, because they're a potential customer of us. And we were talking with a senior analyst about how they do DEC7 reporting. And instead of saying, hey, this is our shiny solution, right? It will solve all of your problems. We asked, hey, how you gather the data? What is the biggest problem with this data? How do you prepare the report? How do you manage sending the report? And so on and so on. And only in the end, when we understood, like, hey, this is what we can do for you, we could say, okay, this is your pain. Looks like this thing can help you with. So let's have a further conversation. And it works much better. So validate your problem by asking the right questions. So yeah, so always ask instead like, would you buy it? How do you deal with your problem now? And more importantly, ask how much money they spend on the problem. Because as I already mentioned, part of the problems will be like, okay, but we pay our intern like $100 a month to solve this problem. Do you want to automate it? No, because they won't spend more than $100 a month. So this problem doesn't worth solving. Go find some other problem. All right. So at this point, you asked the right questions. You found the pain. You validated there are some people that want to pay for it, at least some money. Now you need to understand how to build the solution. And this is where engineering actually comes into place, but not right from the get-go, right? So how do you understand what you want to build is you formulate the requirements. The requirements will ask the questions, what and how, right? So the first part, the problem itself, answering the question, why? Now we have those two questions to answer. And typically, the requirements actually broken down into three groups. First one is functional requirements. Functional requirements answer the question what the system should do, right? So what should happen? For example, if you're building a messaging application or mailing application, you can say that when a button is sent, is pressed, then the message is sent and visible by the counterpart. Or when a user finishes the registration, we send the confirmation email to the mailbox that they used for the registration. Or if we're talking about invoices, we can say the invoice should have price information, tax information, and total all together. So this, what systems should do. This is a functional requirement. Then after functional requirements, you go with non-functional requirements, which are also known as quality attributes, architecture characteristics, depending on the literature, okay? So non-functional requirements answer the question how the system should behave, right? So we send the message, how fast it should be delivered, right? How many messages we will be able to send. What is availability of our system? So how much downtime we can allow for our system, or how secure our system should be, right? So that's non-functional requirements. And actually, the last group is constraints. That's some non-negotiable requirements, not interested for now. So for non-functional requirements, we can say that there's a list of like 50 plus different utilities or architecture attributes. Extensibility, performance, security, availability, maintainability, interoperability, adaptability, blah, 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 blah. On the Wikipedia, you can find the whole list. Thankfully, we don't need to always gather all of those requirements and not satisfy all of those. There are typically like top 5 that you definitely want to ask for. Availability, performance, security, durability, security, fault tolerance, something like that. Others you will figure out during the conversations with the stakeholders. Okay, once you gathered the requirements and understood them, then you need to come up with some kind of a solutions, right? So now you have the inputs, you have the pain, you understand what you need to achieve in the long run, but then you will face trade-offs, because always when you have requirements, you have what? You have contradictions in the requirements, right? So, for example, you want to build a system that is fast. How do you do that? You go with a parallelism. But parallel programming requires a more sophisticated system. It takes longer to build, so essentially the cost rises up. So if you want to save on the cost and make it faster at the same time, you have a contradiction, you need to prioritize. And it happens everywhere with almost any pair of the requirements. So what you need to do as an engineer, as an architect, you need to go with trade-offs, right? So will you do it faster or more secure, or cheaper or faster, and so on and so on. Scalable or working. So your job is to actually make the appropriate trade-offs. How do you do that? Well, you actually prioritize the requirements according to business value and to architecture impact. You build up some kind of an utility tree, prioritize this, and pick up the requirements that needs to be satisfied first, and everything else should be a trade-off. Okay. So, all right, now we need to satisfy requirements. How we typically do that? Well, if we see that we need strong consistency in our data because we have a financial application, well, we pick up something that will give us that guarantee. In this case, relational database. If we want to grant some certain level of performance in our solution, we do with the performance tactics, right? So we do appropriate data modeling, we go with the database indexes, we apply caches, we go rate limiting, and so on and so on. If we want to grant some reliability to our systems, we go and analyze for single points of failure, we do monitoring, we do fallbacks, we apply all the other tactics that we, as engineers, we know. But you see how late in the process those engineering architecture tactics comes into play, right? So we need to make a lot of work about validating the problem and gathering the requirements to actually start doing any engineering whatsoever. Yeah, and so on. All right, but then you need to make some decisions, right? So they will base on the requirements, on the business context, and on the problem impact. So you need to fill in the whole picture as an engineer of what problem do you build, what is the market, what are the constraints, and what is the problem impact, and try to fit it all in. Because if you over-engineer the solution, how part of you fear, right, according to the poll, then if you know that there's only that much money to solve the problem, you want not to exceed this budget or be much lower than this budget. Otherwise, your solution will be too expensive and nobody will buy it. All right. Right now, I want to share a couple of approaches how I approach those solutions in our company and in previous companies. So there are basically 3 ideas of what we need to do to actually build appropriate solutions. Let's go. The first approach is a frugal architecture. So as you might have seen on the screenshot, I was talking about the frugal architecture maybe a year or a year and a half ago. And that was pretty successful talk, I think. You can re-watch it on the YouTube, either on my YouTube channel or the YouTube channel of DEVCLUB. But the idea are the following. So first of all, you need to maximize the impact of the unit of change. We will talk about estimations a little bit later. What does it mean is that according to all the work that you might do, you don't want to do that like in just random order. You want to look at it, prioritize it, and pick up something that will give you the most benefit at the moment, right? So, for example, if you're building something and you go in for the security, that's probably a wrong call because you don't have any customers yet. You need to build something to validate your product market fit rather than make it very secure. So I made this mistake like 10 years ago with one of my first startups, and we built like the most secure messenger in the world, but it was the least used, right? So we were top like 2,000 users. So the amount of work that went into making it secure, it just didn't pay off. So don't make the same mistake. But frugal architecture is not about saving on everything, okay? It's also balancing cost with strategic investments, right? So you can say, okay, I can do everything by myself, not hire anybody. I won't be consulting with anyone. I won't buy any tools because they cost money. But that would be a wrong call. So if you have some kind of a good idea that you see has huge potential, then probably it makes sense to invest in the tooling, in the co-founders, in hiring people to make it faster. Because time constraints, they don't go anywhere. And if you're like just late, then you're late. Okay? So that's the idea of frugal architecture. So you maximize impact, but you actually don't want to save all the costs, but balance it with strategic investments too. As an example of this frugal architecture, I want to share how we started at Supplied, like a year and a half ago. So we started with super lean. We were completely serverless. And we started with a common framework. So I just picked up Nest.js and React for the front end because it was super easy. And everything that was non-core domain, so authentication, monitoring, crash reporting, anything else, it was all external tools and external vendors, right? So I didn't spend time on implementing my authentication or like user management or whatever. We just went with this. The only thing that I invested my time in was the CI/CD from day one, because the velocity for such kind of companies is crucial, and the faster you go, the better you can understand what you're building in the first place. So CI/CD was no-brainer. I just spent a couple of days setting it all up, and it paid off like, I don't know, 1,000 times. However, with time, when we faced growth, when we achieved our first 50 customers, what we saw is that quality demands, right? So people demanding appropriate quality in every aspect of the solution. Second, we understood that certain features like payouts or reporting and so on, they do require appropriate testing before rolling out to prod. And there was some compliance pressure because we are certified by ISO 27001 and GDPR. We're looking to be certified by SOC2. You can't operate otherwise in the compliance field. So we kind of have to put some certain procedures and practices into place. So what we decided in the end is that part of the problems will be solved with infrastructure as code, right? Because like we had to have a staging environment before all the development was just in the production. So staging environment will unlock, first of all, testing. Second, it will provide the appropriate separation of data. And third one, we would be able to prove that some certain functionality works fine before rolling out to prod and to the customers. So we invested in infrastructure as code. So we hired a developer and let him spend 2 months to put everything in the Terraform. So in the beginning, we had like a couple of Lambda functions, an S3 bucket, and the table in the DynamoDB, right? But now it's like tens of Lambdas. It's 2 dozens of S3 buckets, 2 dozens of DynamoDB collections. They're all interconnected. There are queues there, and so on and so on. So we decided that in order to come up with a staging environment, it will be much better to invest in infrastructure as code, put everything in Terraform, but have a guarantee that we have very similar environments, and we can test everything there. So we did exactly this. So it roughly costed like 15K. If we would see some bad releases, we will see clients churn, which would be impactful. And failing compliance check, that's wasted time, plus lost opportunity, plus potential fines. So investing 15K of work into this is actually very good ROI. Okay, because one bad incident could cost us a customer, and it will erase all this investment. So ROI was good. So it was a good decision from this frugal architecture standpoint. All right. Of course, I won't let you without talking about AI because it's 2025. Another approach, another guidance, or another advice that can exist now is, of course, use of AI. And I am sharing our experience as a company of usage of it. So we actually like kind of AI-first company. What does it mean? No, it doesn't mean replacing the loading indicator to thinking indicator because we are AI agentic stuff, right? No, it's a very deliberate use of AI in different aspects. So what do we do? So first of all, prototyping. I will tell you more about this. Second, we are leveraging code assistance. Everywhere we write code, be it Terraform, TypeScript, some other code. Also, we're actually able to do some full feature development with Agentic AI. We do close some of the expertise gap because you can't hire all the experts for a company, and it provides huge legal help with, for example, summarizing the legal documents or finding the caveats in those documents and so on and so on. But let's get closer to the deal and let's see how AI can actually help us in building at least prototypes. So for us, it was very helpful because instead of drawing something in Figma and waiting for 3 weeks, we were able to come up with like literally 5 minutes and show it to the customer, get the feedback. Remember what I was talking about in this mom's test book. So let's see it's in action. So just today, what I tried specifically for this talk. So I decided that we can follow this Google trend. Remember this Palgar calculator, right? So now let's try to build a solution out of it because it's obviously demanded. So what I came up with is this prompt. Write me a salary calculator for Baltic states for budgeting and tax optimizations. What do you think I got as a result? Bullshit. Okay, good option. More ideas?
Python script.
Python scripts. Okay. Who thinks I got something decent? Okay, a link to the existing solution. That's a nice option. Any other opinions?
Using AI.
What using AI for what?
It asks for the task, what do you want to give me numbers?
Okay, let's figure out.
Sorry, which model you used?
Doesn't matter. So, first attempt. This is a result of work of Kiro. Who has heard of Kiro? Yeah, not many. So Kiro is a new AI-based IDE from Amazon. So basically the idea was that you put in the request, it will think, it will ask you questions, it will come up with a plan and execute on the plan. So my experience with Kiro is that you download it, it's invitation only by the way, you download it, it prompts you to give her, I guess, the prompt, you type it in and then it says like open a folder where you want your solution to be in. I open the folder and what it does, it forgets the prompt that I gave it, okay? So I had to start over. Thank you very much. AI from Amazon, okay. But after another iteration, so I gave a prompt again, so it was able to come up with this. So this is a very basic web page saying like, hey, gross salary, employer perspective. Well, not very bad for just like 3 minutes of work, right? So probably I would be coding this for 20 minutes or half an hour. So, but still meh. Okay. Then I decided to attempt a better approach. So first of all, I decided not to use Kiro anymore because it was obviously not doing what I was expected. Second, I decided to go with the approach which is called meta prompting. So instead of writing the prompt myself, I decided, hey, I have AI for that. So I went to ChatGPT, I put there like, I want to build a salary calculator. Now give me the damn well prompt to do that. And it was able to do like just that. So I will show you. So ChatGPT here. So in the beginning, so you see the exact prompt that you saw on the slide. It's thought for 6 seconds, and then it gave me the prompt. Okay, that's the prompt. All right. So I'm still scrolling. That's the prompt. Now what you do in the meta prompting approach is you go to some other tool. There are plenty of tools that you can use for vibe coding, like Lovable, Bolt New, Replete, anything else. You apply this, and the result was surprisingly good. So I went to Lovable, and it was able to come up with this, okay? So it's not bad, all right? So employment type, calculation direction, accountant for pension insurance, the breakdown, the graphs. So it was not bad. Until the moment when it ran out of tokens, of course. So and decided that it wants to charge me $25 for continuation or for fixing bugs. But that was not bad, okay? So it took like 5 minutes and this is much better than I would do in an hour or 2 or 3, okay? So that's already good. Then what I did, I actually tried a couple of more approaches. So I went to JetBrains Juni to ask for that. The result was very bad. So it was just a black HTML page with some labels there, so it doesn't count. So JetBrains Juni doesn't work like this for like first prototyping, I guess. Then I tried Bolt.EU, but it ran out of token again, even before giving me anything. So not recommending this as well. But the idea here is that for your products, you can vibe code it really fast. So it's a big shift from what we had even a year ago, that you can come up with some MVPs or clickable prototypes very fast and go validate your idea, okay? So, vibe coding prototyping. So please choose the tool that works for you. You can ask ChatGPT what you want to do, and it will give you the ideas of tools that fits you best. Second is that it decreases the feedback loop drastically. So what you probably had in the past is you would have a product manager, they would go to a designer, they would explain what they want to build, the designer will spend 3 weeks in Figma, then with this Figma you go to the developer, spend another month building it. So now you can compress it into 15 minutes with meta prompting and lovable tool or Bolt.EU tool and come up with a prototype which works. That's amazing. So yeah, feedback loop 1,000 times faster. So that's very good. However, it's not limited to just prototyping something. You can use these AI tools now for feature development. So this is a screenshot from our real project from our company. And you can see the prompt, right? And it's pretty sophisticated because I used meta prompting again. So instead of just saying, build me the feature, I asked ChatGPT, give me the prompt to build this feature. We had a nice conversation. We came up with a prompt. This prompt I put into the JetBrains Juni, and then it wrote a lot of stuff, okay? It was almost workable. I had to fix a couple of items here and there, but in the end it worked. So that works very well, and it actually improves the velocity that we can go with. Okay, but so my idea is that you can use those AI tools for feature development as well, and for searching for the product market fit, and for the sake of velocity, it is crucial, right? So if you're still hand coding everything by yourself, you're missing out. Stop doing this, start learning AI tools. So what do we typically do? We prepare the prompt. However, the best practice is that you need to control the result. So there's a joke again that engineering managers are prompt engineers from day one, right? So what they have to do is to go to the developer, ask them about something, then go away, don't look at the code, get back a week later, ask to fix some bugs, go away. So right now you do everything the same, but you talk to the developer and you talk to the computer, and instead of a week, you wait just for 15 minutes. So engineering managers do that all the time. From my standpoint is that you need to control every piece of results, so you need to review the code rigorously. You need to ask for the unit tests, and you need to review those unit tests again, because even if it is able to come up with decent unit tests, it may make a mistake in some place that will ruin your idea, so you need to control for that. But reviewing unit tests is much easier than writing the code base by yourself. And yeah, test it extensively, so verify every edge case that you would do. Okay, that's about AI. The last thing, I promise, that's the last one, is fierce prioritization. So here you can see the honey badger, and this is the mascot of Bolt, okay? Inside Bolt, they even call employees honey badgers, because honey badgers are fiercely aggressive, and they don't afraid of any competition they have outworld. What I want you to do is to apply the same principle, but to the prioritization, okay? So any successful company, even somewhat successful company, they will always have more work that can be possibly done, okay? Otherwise, it's not a successful company, okay? So if you run out of work, you don't have an idea where to put effort, you don't have a proper company. So you need to prioritize. And this is one of the keys how to build solutions that work. So how to do that? There are many approaches how to estimate it, how to prioritize. I will tell you about one, which is called WSGF. So work shortest, job first. The idea of this prioritization framework is to measure the cost of delay divided by job duration. So what does it mean? Let's look at the example. So to the denominator of this ratio, you will have the business value plus criticality plus risk reduction. So what does it mean? So business value is something that brings value to the customer or to the business. So you can think about the revenue that you will generate, okay? Criticality is time bound. So think about marketing campaigns or incoming regulations or customer deadlines, something that is time critical, okay? So that's the second parameter. The third parameter is a risk reduction. So it's either reduction of risk, so you are avoiding fines, for example, or it's opening new opportunities. For example, you will implement a feature and you will start selling new product to your customers. So that's opportunity. So you need to somehow measure this one. So product managers typically know how to measure all of those things. So all you need to do is to collaborate with them. And then you will just estimate those for every feature. What you do as engineering managers and the architects, you need to estimate the job size. So this is story points or parrots or man months or any other value that you can reliably come up with. So this is like job size or the effort that you need to spend on the feature. Then you come up with a simple table and then you apply a simple formula. So you sum first three columns, so business value, criticality, and risk reduction. This is cost of delay. And then divided by the job size. And you have this relative metric of how much value we can capture at what effort, okay? And you obviously want to optimize what? So what's the best value here? B, exactly. So we capture the most value at the lowest effort. So the ratio is best. So you just sort it according to this value in descending, and that's it. This is your prioritization list. So we do very similar thing at our company and still like looks fine. Okay, that's it from my side. Short summary. So what you do? Find the pain, validate the solution worth it. Second, build prototypes and get fast feedback. Third one, be frugal and prioritize. And apply this iteratively, okay? So build the solution, get the feedback, iterate. That's it from my side. Thank you very much. If you like the content, so I have consultations, I have courses. So first of all, there's a business-oriented design course happening right now. I mean, we started with the first lecture, but you can jump in if you're interested. There's also a second course for Engineering Managers 101. So if you're a fresh manager and don't know what to do on your job, that's a good course to attend. Also, I have a YouTube channel and Architecture Weekly newsletter. Everything you can find here on the site, and the QR code goes there as well. That's it. Thank you.
Okay.
Questions?
Questions?
What the hell is going on?
I have a question.
Sure.
Thanks, it was a great presentation. You said like your AI, the model, the prompting, sometimes you get. Have you ever tried the memory? Because the memory solution is now gaining popularity.
Yeah, we do several things. So first of all, one of the approaches is to have a plan markdown file, right? So you ask for the plan first, and then you ask the model to iterate after the plan. And if you see it's stuck, you can say, okay, like redo point number 3 from this plan. So that's one memory thing. Second, we haven't used any RAG whatsoever, like haven't got to it yet. We are evaluating MCPs right now. So what we want to do actually, a funny experiment to see, is like we spend a lot of effort right now for the front end, and we have the designs in Figma. So we want to use Figma MCP to use this agentic AI to do the work for us because like just copy pasting style is very boring. So yeah, that's the second thing. And that's pretty much it. Talking about the experience with AI, recently we tried to connect Cursor to our issue tracker. And now you can do a very fancy thing. When you see a bug, and it's very easy and you don't want even to spend time into going into it, you can go into issue tracker, you can just tag Cursor, and it will do the pull request for you. So it will check out the code base if you connected the repository. It will fix the bug, show you the PR, and then you can just review the PR or check out this branch, see that the bug is fixed, and approve the pull request or ask it to redo it. So that works nice, yeah.
I think the PR creation was kind of started by the IA, as you mentioned earlier.
Yeah, okay. Any more questions?
Yeah, maybe it would be fair to say that this approach doesn't work everywhere. Maybe you also talk about things where it doesn't work, right?
Yeah, so what doesn't work, you mean AI, right?
No, I mean like the whole talk.
The whole talk.
Like for example, like imagine you're doing some juvenile, right? Or you do some like highly regulated financial services, and you will not come out like, we did some AI prototype, will it solve it? Like there are certain situations when you cannot afford this kind of thing.
Yeah, so if you're pitching AI into accounting products, that's probably a bad idea, right? So I'm not sure you saw that, but there's a screenshot of yesterday where there's this Google AI and Google Sheets, and there's like, please sum up the columns above, right? And it makes an obvious mistake. It's like, what the hell is going on? So don't apply AI everywhere. However, about this, like the whole talk approach, with financial services, it's perfectly fine to approach it like this, because financial regulations give you the pains right away. It's even simpler, right? So they will tell you, you need to do this report. Okay, great, the pain is there. The validation is there as well, because if they don't abide, they either lose a license or get a fine. So you have a cost estimation already. But so yeah, you can approach this. However, I think about the example where this approach doesn't work, and it's like creating completely new niches. Okay, so you won't be able to use this approach to create a new market. So nobody will tell you that they wanted an iPhone in 2007, right? Or nobody will tell you that they want to see how they will look in the old age, speaking about Prisma and face masks, right? So nobody will tell you that. So there's no pain to discover. It's like completely new creation. So this approach doesn't work. However, verifying this still works, right? So when you come up with the idea, still go with the prototype, show it to the user, and then when you see there's explosive growth, then apply every best practice that you know about. Yeah?
My question is kind of related. So I think you're right now thinking as a startupper that like software as a service, you're a product, you're selling it to lots of customers. But what if you're working in a consulting company and you have projects instead?
Okay.
They are very fast rotating, and so when a customer comes in, let's say it's an old school, outsourcing company. The project comes in, and it's all the time it's different topics. There is no like problem discovery of the market. If, a customer has a problem, and now you are not developing a company. You already have fixed positions, fixed engineers with their own mindset, and they don't see the full verticality like you do at the moment of the project. So how would you change in that situation?
Well, I used to work for a service company for like 4 years, and it's completely different because what you do is the customer knows the pain. They typically have a budget already, right? They have certain expectations from the solution that you can collect. What you would do is you relax and just execute on the project plan. So you estimate the solution, you hire the developers, you begin to show the results every week or 2 weeks. That's it. So, but that's boring, right? That's why I don't work for service companies anymore. Okay, any other questions? No, then let's go get pizza. Thank you.